Welcome to the Stewart Squared podcast. Got another exciting episode. We're going to get deep into data training with Threads as the competitor to X. Elon Musk is building his Neuralink castle where he's going to try to create brain-controlled interfaces, and he needs a lot of training data for that. And he's also got his robots, and so Twitter is basically he's figuring out how to train on all of our data. And then out of nowhere, Mark Zuckerberg comes in and creates this much more authentic version of the original Twitter that is now basically given me an outlet to get off of Twitter. I actually have no problem with Musk's politics. I think a lot of what he did during the 2024 election was actually probably smart, just because the opposite was just such a horrible thing. But I
my son is a Muskie.
Yeah, well, no. I mean, but I'm not. I was temporarily allied with him during that crazy time in 2024.
You're talking about Doge?
Yeah, Doge. Like everything that went on from 2020 to 2024, I was strongly opposed against, as were a lot of, I think, the rest of the country as well. But it's just not the fact that it's just we had only two options, and both of those options were not necessarily great. And so I allied with the one that I thought was better. And it's true that it is better, but it's still really shitty, basically.
I don't think it's better. We don't want to necessarily have a political conversation for our listeners, but there's good stuff that is coming out of the Trump administration, but there's always good stuff that comes out of any administration. And there's bad stuff that comes out of every administration. So what was the line? That democracy is horrible, but it's... Yeah. So it's always good and bad. The problem is that Trump is just such a snarky, evil character. Why does he have to go after people and treat them as targets? You can do all the stuff he's doing without doing that.
We definitely.
And then when Musk did Doge, it was it's just like a random walk. He's just whacking away at it without any empathy, or maybe empathy is overblown, but we're still human beings.
And I think this gets into what we'll talk about, because I think the politics is very related. The bureaucracy has become uncontrollable in terms of our country. Why did everything get outsourced to Taiwan, right? It was because of the large managerial grass. Well, no, Taiwan, right? Because Taiwan is the place where all the chips are made. It's not.
That wasn't outsourced. TSMC was built from the ground up in Taiwan. That was not outsourced.
But all of that used to happen in Silicon Valley, right?
No, I know, but TSMC did a better job. That's not outsourcing. Sure. Outsourcing is when you're going, it's cheaper over there. Right? We're going to put it over there because it's cheaper and it costs us less. That's outsourcing. If they do it the right way over there, and the really interesting thing is China does have a company that does semiconductor manufacturing. In fact, it's called SMIC, Semiconductor Manufacturing in China. They just they cannot be as competent at TSMC. They're like several generations behind in terms of the size and density of their chips. So TSMC did something that was not done in the U.S. We actually never mastered.
Okay. Well, that's an interesting point. We could look at, because my understanding of the reason why I went to Taiwan is because the unions in Silicon Valley started to demand much higher wages, and then. So what is a fab? How did the fab idea get implanted in Taiwan first then?
So when we started this semiconductor business in the U.S., you built your own chips. You did the whole thing yourself. You designed them and built them. So you had to have the design capability and you had to have the manufacturing capability. And Intel was the first one to really do that. But in order to do that, you have to correctly predict where semiconductors are going. And Intel blew the mobile, never adopted ARM. They made a bunch of strategic mistakes. That's not on any kind of political thing. They just fucked up. And so there was an opportunity for somebody to build only a foundry. Foundry means making. And that's what TSMC did, Taiwan Semiconductor Manufacturing Company. basically said, look, we'll build your chips for you and we'll do it really cheap and very efficiently. And we have the best process. And so they used the competitive situation to become the dominant builder of chips, the foundry. So Intel, like 10 years later, goes, oh, oops, we should do a foundry too. So they tried to do a foundry. This is the issue. And Lip-Bu Tan has just taken over at Intel, 6 months ago, has basically said, no, we really should be doing foundry. They just screwed it up. So you have to do it right. You can't sit there and have both the making thing for your own chips and a foundry for other people's in the same company without favoring making your own, which is what happened at Intel. And they were still stuck on their old architecture and were not modernized. So he's actually flipping the thing and saying, no, the future of this company is the foundry, but we have to be better than TSMC. Now, who the hell knows if that's going to happen or not?
So
could be a goodbye.
So Intel, did I get it right that they are creating their own foundry, but they're only doing it for their own chips? They're not trying to build other people's chips?
No, they were making a foundry for other people's chips. But say you're another person's chip. You look at it and go, like, Intel makes its own chips. Well, they're not going to do a good job for us. They have to get over the credibility gap, which Intel never bothered to do because 98% of the revenue comes from making their own chips. Okay,
so that's really interesting. So basically, it had nothing to do with the unions that TSMC essentially started to take over, because that was in a book, Chip Wars. I think Chip Wars that I think you read and we had talked about many years ago that said that. But so Taiwan, what they really
the unions are kind of, it's like a red flag. You dangle the red flag of the unions and go, oh, it's their fault because they want people to be well paid. But the U.S. is only like 10% of the workers out there are unionized, right? So it's not a controlling position.
But it used to be.
So auto workers became the standard of comparison, right? Because they were middle-class people. They were paid a fair wage. You can decide what that means, but a wage that allowed them to send their kids to college, to buy houses, et cetera, et cetera. That became the standard of comparison for everybody else. In Silicon Valley, it was a competitive issue. It wasn't unions. Very little union activity in Silicon Valley until the last few years. The issue was that it was competitive, right? People had to compete with each other and they had to pay the good people more in order to be successful. So wages went up in the U.S. across the board, right? We're a rich country. Everybody got paid well. So where do you go to get stuff done? And originally it was, it's just cheap manufacturing jobs. Sure, we'll go do it over there. The point of Apple in China, as opposed to Chip Wars, was that Apple actually exported the expertise in designing chips. And they're still getting
and
TSMC.
Fabricating, right? So designing.
Well,
and
TSMC did the fabrication for Apple. That's the foundry.
Okay, but
Apple's probably 30% of TSMC. I made up that number.
Yeah.
It is probably the biggest customer for TSMC.
But China also both designs and fabricates their own chips. Their fabrication
is behind. That's why TSMC is so important as a pawn in this geopolitical warfare between the U.S. and China. Like 90 miles from the coast of China is the most advanced fab. And, they're building one in Arizona and it is producing chips and, but at an enormous cost at this point. And they've had to export hundreds of people from Taiwan to be able to build the factory. And they have to train and hire people to actually staff the factory, most of whom are not.
Is Taiwan fabricating chips for China as well?
Yes.
So yes. China contracts to Taiwan in the same way Apple contracts to Taiwan.
Yeah, China has SMIC, so they build the old chips. But China has to go to TSMC, and there's no law against China buying chips from TSMC. That's why it's such a confusing mishmash.
Okay, and I'm going to go, kind of into left field going into left field because
left, right, whatever.
No one plays baseball anymore. A lot of Americans do, but Trump recently did a deal with the Department of Energy to use all 17 national laboratories to start using their supercomputers, their Cray supercomputers, to start moving them from climate science, which is what they've been doing for the past 4 to 5 years or 10 years or whatever, because the climate is the most difficult thing to predict. So everybody's trying to predict the climate. And now they've been directed to move from that to start doing cutting edge science with LLMs or some sort of AI technology, transformer based technology, to start doing automated science research. And I find this so interesting and so perplexing. Like, not many people are talking about it anymore, but I was just like, oh, that's, and then I did more research and I found out that it actually comes at the same time as Doge-like cuts to all of the federal science that's been going under. So it might be just like a sparkly thing like that Trump does, which he learned from the previous administrations, which is just basically like, say this thing, say it really loudly. And then meanwhile, a bunch of other normal, boring things that are really important just happen in the while everybody's attention is focused on this thing. So it might be one of those things, but it might also not be one of these things. Do you know anything about supercomputers, about Cray supercomputers and all of this different stuff?
Seymour Cray.
Yeah. Who is he? There's a book I'm meaning to.
He's dead now, but I'm pretty sure he's dead. Yeah, I know he's dead. So he worked at a computer company and got pissed off. I mean, it's like Silicon Valley all over again, except that he happened to do it in like Michigan or Minnesota somewhere in the Midwest. And so he started his own company, Cray Research, and built the first, not the first, because IBM built supercomputers and other companies in the bunch. Do you know what the bunch is?
No.
Burroughs, UNIVAC, NCR, Control Data, and Honeywell.
Okay.
BUNCH. Yeah. They were all the other computer companies that never really figured out how to compete with IBM, but did a lot of research and had good businesses. I don't remember which one he worked for before he got pissed off, but and started Cray Research. But he built, and he had a sense about him. So he built a supercomputer that was round and it had a bench on it. So you could sit comfortably on the supercomputer because it was pretty damn hot. And, lounge. So it looked like it would belong in a lobby or something like that instead of in the back room where, people in white coats. So people noticed that and it became visible, even though nobody had any idea what he'd done. Well, except in the industry. The separation of silicon from the manufacture of computers was something that the personal computer really started. It was kind of already going on, but PCs scaled and required mass manufacturing.
Oh.
So they built their own chips. They built their own software. They put all the wires in there to make everything communicate with each other. And Cray actually built the whole damn thing. And it operated at a speed, I don't even think we were into gigaflops at the point. Maybe teraflops, but floating, I can't remember what flops stand for. It's like floating point operations is probably what it means. And that was the key. The floating point calculation was the kind of core thing that the computer had to do to be able to be applied to all these other things like weather forecasting, scientific calculations, and so on and so forth, solving crypto.
Yeah. So I've already got a connection to AI because, as you may be aware of, there is now a drought of VRAM, and Sam Altman basically cornered the market on VRAM. So like high
V
quality,
as opposed to D?
I believe so.
D is dynamic RAM and V is virtual RAM, I believe.
Well, whichever one is really the most important for data centers. And so he saw it coming. He saw what is now currently happening, which is a glut of, I believe, VRAM, which is the high bandwidth RAM that's needed to connect all of the different GPUs together and across there's a connection point where they network all the GPUs together. And that throughput between those things is really important. And VRAM or some high bandwidth RAM is really important for that
DRAM.
specific. It's DRAM?
DRAM.
Okay, good.
DRAM is hardware RAM, the memory, random access memory. DRAM is, I can't remember what D stands for, but
Dynamic?
Dynamic, which means it's a piece of hardware that has a lot of memory on it, but can store new data very fast, as opposed to RAM that's static. So SRAM is the the other one. I don't think there is a VRAM, but can look it up. SRAM is static memory. And that's where you know what the application is and you embed it in a device and it always works, but it's not dynamic. You need dynamic in a computer that's constantly doing new calculations so that you have dynamic RAM. You can fetch and store the data from memory and without losing it, basically. DRAM was the beginning of the personal computer industry. And actually, if I remember correctly, Intel started as a memory company.
Interesting.
Making DRAM.
And so, but regardless, one of that there's some sort of memory thing that's been totally cornered by Sam Altman.
I just looked it up. That's DRAM. Sam Altman and ONAI have made headlines for securing massive deals for DRAM memory chips, which some reports indicate amount to a substantial percentage of global supply. So he's cornered DRAM.
And so that's going to like basically what you were just saying about this computer, about the supercomputer that Craig basically had to construct on his own. And you said something really important about silicon not having the whole consumer PC behind it. So he had to basically construct this whole thing. And it reminded me of the economics of scale that we were talking about with Taiwan. And now we're in this place where LLMs and transformer architectures are requiring so much GPU manufacturing and the hype and the $80 billion in Microsoft CapEx for data centers in 2025, and all the other big tech companies investing huge amounts of money. Part of it's hype, part of it's Ponzi, part of it's not. And so it's going to totally change the PC market, it feels like, because it's all getting sucked into this AI data centers. Do you think that that's going to happen?
Yeah, I was just looking up. Seymour Cray died in 1996. Pretty pivotal time, right? That's just when the internet was getting started. Prior to that, there was no big network. DARPA had a network and supercomputers were connected to them, but there wasn't the kind of scale you're talking about. So you have to always put it in context why we do this podcast, right? To know when something happened in the context of what was going on. So by the time he died, and I don't know what his last years were like, but the industry that he worked in completely transformed, right, to one of scale, where personal computers were driving the demand for both CPUs and memory and all the associated stuff in it. And that's when supercomputers became an incredibly specialized category of computers. And it's interesting to me, when you say the 17 national labs, are they really using Crays now? They may still have their Crays.
That's why I brought it up this morning. If my research is right, there's like 4 of them that are still using Crays.
Which they probably bought, 35 years ago or 30 years ago?
No, but they're still using supercomputers from 35 years ago?
Well, if they're using Crays, because Cray died, Cray Research itself was sold to another company. And, who knows what happened to it after that. I don't think there are any Cray computers being produced, at least for the last 20 years. There are supercomputers, but supercomputers have changed definition now. This is part of why I thought, my prediction that the mainframe would be unplugged was accurate, because you can't defeat scale, right? Once you're into a scaled environment, you can't do little handcrafted chips. You have to operate at scale. And IBM makes... Because, you're going to go out there and build a new computer over a period of 3 or 4 years. Meanwhile, the whole business has changed on you.
So that's the problem that China's in right now, is that whatever they produce, we will have produced because we have scale of economies in terms of chips, quality of chips, right?
Not sure exactly what you're...
So I believe what you just said, and I feel like it's really important, is the reason we don't have a mainframe, reason we don't have these large supercomputers is because it takes this crazy customized ability that can't compete with the next generation of chips or computers or silicon, because the next generation at scale comes in 6 months. Whereas while you're still
pushing the edge of what I know here, but IBM still makes microprocessors or processors. I don't know, central processing units. They still make chips. They have a foundry in upstate New York, I believe.
Yeah. Oh, interesting.
That makes chips for themselves, right?
Yeah.
Now, they can't do that for the PC or for mini computers or really even servers at this point. but they still do it for their supercomputers or their really big mainframes.
Interesting.
What's happened in this, and this is where I think I'm right, but I'm not totally sure, is that you now have clusters of computers that act as supercomputers, right? So they're networked inside the computer, and the actual devices that do the computing are mass produced. At some level. So when IBM sells a mainframe, they may like package it and make it look like a mainframe, but it's actually a bunch of personal computers, microcomputers, all cooperating with each other at speed through a local area network or even a bus-based network. And so they can do teraflops or gigaflops or wherever we are now. But the components of that are mass-produced, no longer hand-produced, so to speak, hand-produced by an individual company. You still have to hand-produce if you're at the level of a supercomputer. And that's why I'm like, that's on my edge. I don't actually know if we actually have supercomputers the way that Seymour Cray thought of them.
So, what you said about clusters of supercomputers are normal computers that are just networked together kind of goes back to everything we've been talking about, how important the internet was, because it's the network, and not only the network of the internet that allows us to do this call, but the network inside of companies, the network inside of GPUs, right? Because a GPU data center...
GPU is a special purpose chip, so you have to put that to the side. But inside of a computing device... Like when I talk about these server farms for processing LLMs, that take gigawatts of power and, they're stretched for acres. And, that's a bunch of computers all sitting inside a building. Each computer is talking to all the other computers at the same time. So one of the issues that happened as these server farms were being built originally for kind of database management, now for processing LLMs using a GPU, is how do they talk to the other computers in the server farm? Because originally you put all these cables in there. I mean, if you go into a server farm, there are a lot of cables. And the individual cables could only handle so much traffic and pass it along at a certain speed. So the gating item actually became how they were connected together, not their processing. And so then they adopted fiber optics, and they've become very good at this, right? So the fiber optic networks inside of it at a server farm operate much faster than the old server farms were able to do, because that's critical when you've got that many processors operating at the same time. And that's another leading edge area of research now. How do you get computers or computing devices to talk to each other as fast as possible so that the collective of all of the computing devices ends up looking like a supercomputer?
Well, that's kind of trippy what you just said there, because like a mainframe is a networked computer, but all inside of one computer, right? Without the cables.
Yeah, this is where I probably talk to an expert in computer design, and they'd tell me where I'm wrong. But this is the impression I have, is like, scale microprocessor. We look at these things. This phone I have here has 2 terabytes or 4 terabytes of memory in it. Terabytes of memory in the device. And it has these highly sophisticated, very high performing ARM processors in it. And these are all packed to have, like, when you talk about a microprocessor, it's now just a little piece of the chip, right? There's memory on the chip. There's GPUs on the chip. There's all of the other different things, the communications. So a computer or a microchip is really just a design of a component inside of a chip. So the only, and you've saw, I'm sure you've seen the pictures where the whole computer is like right here, right up at the top, which is why that had to bump out, and the rest of it's battery, right? So if you look at this as a sort of functional individual device, imagine putting 10,000 of these inside a server farm, or 100,000. I don't know what the numbers are, but then the problem becomes, how do they talk to each other?
Well, and then the trippier extension that I was thinking about with the mainframe was that mainframe as a computer networked with a bunch of chips inside of one computer. And then I want to figure out when that happened. When did that happen? It was in the 1980s where they started to think, we can just network more mainframes together to create a super mainframe.
No network. There was no network. So until you had the network, 94. you couldn't even. Well, the internet started as a commercial network started in 1994, but it had to become fast enough to be able to communicate between all these devices. So,
Yeah.
The thing that we're doing right now, you're sitting in Argentina and I'm sitting here in New Mexico. I've got much better internet than you do, so yours kind of slows down from time to time. But it's pretty amazing, right?
Yeah.
The speed at which our audio and video is going back and forth, and Riverside's dealing with them separately and merging them afterwards. But that's amazing. That's just like table stakes. If you're going to have microprocessors operating at whatever their speed is, communicating with each other, then that communication has to happen at an unimaginable speed for us because it's beyond our perception. This is chips talking to each other.
So and I'm finally able to get to it because you just mentioned it as well, because it's like it's not only just a mainframe went away, but also we networked a whole bunch of computers to make a supercomputer out of a bunch of smaller computers. But also the fact that the internet connects the entire world so that all the computers are connected together into one giant supercomputer, which is now being...
So then you go to the level of what's between the data centers. If you're a data center in Texas and one in Taiwan, what's between them? And how fast can they communicate with each other? Right? That's the cloud. Bingo. That's, the definition of the cloud is what's happening in between all of these massive data centers. That
is the data centers connected together by digital fiber optics and undersea cables and now satellites. Are there other things that are needed inside of that whole infrastructure, like to get from Texas to Taiwan? Are there like a bunch of things in the middle?
Sure. The satellites that are orbiting in low Earth orbit as communication satellites, there's a thought, not yet implemented, but potentially implemented, particularly in national security, where the satellites can use lasers to communicate with each other at extraordinary speeds because it's in space with no air in the way. There's always, anytime you hit a leading edge, there's always a solution that's beyond that. We invested in a company, I'm proud of this, called Kuprion.
How do you spell that?
Kuprion. And it's derived from the symbol for copper. Copper is a highly transmittive, very useful material for transmitting data on a chip. But it's very hard to handle. So this company figured out how to produce a paste made out of copper that you could stick between chips so that on the chip and between the layers of the chip, you would have incredibly high speed communication. That's a very simplified thing, but amazing I even understand it. But we sold that company to another company because a little company trying to integrate kind of a material into chip making is a very difficult proposition. So we sold it. As a business, a company got sold to a public company. This is all publicly known. But the issue is, how do you get somebody to adopt that, right? Who is making a semiconductor and wants to integrate? Well, if they're making millions of chips, they don't want to depend on some underfunded little startup company to supply materials. They just signed the first contract. The acquiring company just signed the first contract. Yay! And they're building 2 factories to produce the material, one on the East Coast, one on the West Coast. This is all American made, top to bottom. And so, this is kind of where you get the fundamental concept here is Moore's Law. Moore's Law was that the performance of semiconductors would double every 18 months. And it did that for 40 years. But people are worried because now it's getting down to nanoscale. And it's much harder to achieve that kind of performance improvement. And so one of the things that's happening is they're stacking chips. So in other words, you look at probably an NVIDIA chip, but at least a ARM processor, that chip will actually be made out of multiple layers, each of which has all the different components on it. And so it operates as a single chip. And the speed of communications between the different components is infinite because they're right next to each other. And, but then they overheat, and there's a bunch of other issues. But
in a podcast yesterday with this guy who's building the first, I think, not commercial, maybe the first commercial AI data center in Argentina. He finally explained to me what was going on with the heat. They always talk about the heat inside of silicon and the GPUs is a huge problem. And I was like, well, why don't you just heat your house in the winter with it? And he's like, no, that's not the issue. The issue is how do you get it out of the silicon into something, and you get a radiator. And that's the main technical problem. It's not what to do with the heat. It's how do you get the heat out of the silicon as soon as possible. And so we could.
You did that in Spanish?
No, this was in English.
Oh, okay. Yeah. So here's my learning. At our firm, also Poly Partners, someone would come in and say things every once in a while, and we go like, "Wow." He came in 2010, 2011, 12, and said, "Okay, power is the problem."
Mm-hmm. We're all got it right.
What do you mean? These are like computers, and they use a little bit of power. He said, "There's so many of them; they're so densely packed. It's hard to get all the power in to the data center to operate all those things because our power system is distributed. Right? You have to concentrate at some point, and so they built data centers on the banks of big rivers, so they could use hydropower." So they've been working on this for whatever it is, 10, 12 years. The second problem is heat. So how do you keep this stuff cool so that it'll operate well? Well, a lot of those data centers are next to water. So they started using cold water to cool the process. But we're back to power now because there's so much power being used for these AI data centers that it's actually become a national security issue that, suddenly we had been moderating the use of electricity and suddenly it's spiked again. Right? So where are you going to get that oil and gas and all the crap that's messing with our environment? You got to stop worrying about the environment so you can supply the power. But this is how it happens. It's like this, and it all has to go in tandem. Because if one of them doesn't move along, batteries are a big issue right now because they don't move as fast in terms of the technology, if you will, of batteries. It takes forever to get 10% improvement in batteries.
But one of your companies recently did have a win in terms of that, right?
The Wall Street Journal wrote an article about them. That's right. Considered a win. Yeah. But, they actually are making what are called cells. Also, all batteries are made out of cells. They are producing cells at a very low rate. So they've demonstrated that they can do that and it works. Their issue is how do you produce the stuff that makes that battery?
Oh, interesting.
No car manufacturer wants to buy a battery that has one cell. You have to have
how to mass produce
cells.
It. Yeah, because that's the issue.
And it's a material. It's a powder.
So, and this goes back to what you're just talking about, the copper, because that's the same problem with the copper people too, as well, is that it's not necessarily just getting to the prototype or or even the first contract. It's like, how do you deal with the fact of getting up to 100?
How do you solve the whole problem?
Yeah.
How do you manufacture it? How do you integrate it? How do you change the lines? People that make semiconductors, that's a really intense process for doing a highly scaled manufacturing process. So how do you change that to make this new stuff at the same scale? So you have to kind of work your way up. And when does somebody decide that it's enough proof that they can take the chance on it? Which is what just happened with Cuprion. There's a big multi-billion-dollar company that signed a contract to buy this stuff.
And those companies are there's a small amount of people who can actually make the decision. So it's not only do you need to build it, but you also need to. That's the sales part where you identify that
part. Yeah. But imagine, what's the Dutch company?
ASML.
ASML that makes all the lithography equipment, right? Yep. It's the only one left.
Yeah.
It has 100% of the marketplace for lithography. And imagine trying to build a competitor to that by venture, right? With venture capital. It's like, no venture capitalists would touch that.
Interesting. So
unless there was some major change. And, how do you change the process of lithography? Is basically just taking a picture of something.
it's so strange because that's like gets into where I wanted to, or I've just been thinking about the last few days is sort of BS jobs. There's this author, David Graeber, who wrote this book, BS Jobs. And a huge part of the millennial and the Gen Z existential crisis and angst is that all of the jobs were shipped away, and then we had the remote work thing in 2020, and everybody was like, "Finally, yes, I can work remotely," and then all the jobs really went away, and now we're stuck in this sort of like strange. But part of that's true, but part of it's not true. Part of it's just like the social media narratives, the narrative like napalm tsunami type of thing, where it's just like it's not just that that might be happening or not. What everybody thinks it's happening. And everybody talks about it on social media. So it always influences your thing. And so it feels like what you just talked about gave me a sort of insight into our economy in general, which is that there are real things being done in the United States, but they're at such crazy specialized things like what you just talked about with the copper and ASML and all these different things. It's just like such a extremely specialized thing that there only a few people in the world could even understand that specific job. And so it's like those jobs are really important, but all of the other jobs are now not. And then you have the AI narratives, which are saying, well, now all of the other knowledge work jobs are also sort of at quest.
It's also at a business level. ARM is a really interesting company because it's been around for 40 years and started as a British company called Advanced Research Machines. But it didn't become ARM until much later. They designed a architecture for a chip, right? So when somebody adopts an ARM architecture, which Apple's done and Amazon's done for its server chips, and
Raspberry Pi,
Raspberry Pi, don't know if TPUs are on it. If you say it's an ARM, you're paying a little tiny royalty to ARM to use their architecture. But you're actually doing the foundry, you're doing the design, you're doing all the rest of it. So they're just like this little layer right at the bottom of what's now probably, I don't know, 70 or 80% of the design of microprocessors or microprocessors. And so they're a multi-billion-dollar company. It's kind of like Google, charging a penny for a search and having trillions of searches make it up in volume.
Yeah, so there's also these really interesting new business models that can appear. Well, this is a really good question because it's like, how did ARM? I'm sure there's a history to it, but you've done early stage investment for a long time, and everything you said about early stage investment is essentially like I think it's probably like from 10 or 15 years ago. I once asked you about whether early stage companies have a great story, and if they don't have a great, crazy, serendipitous story, it's not something real. And like some examples of that are Justin TV, Cruise. Well, Justin TV led into Cruise and Pokemon Go. All these companies have really interesting stories. The ARM story, like, because that's the sort of creativity I've seen from you in this business stuff, is just that it's really chaotic and creative. Meowwolf, like Meowwolf is a chaos, but then there's a business there. And so like this ARM thing, I'm sure there's a great story. And I kind of looked it up here. The Core Insight in 1990, they spun out of Acorn Computers. They made a radical choice. Don't manufacture anything, just design process architectures and license them. It also makes me think about like, where's that headed with AI? And like, what are the crazy?
Acorn was one of the first personal computers. It was designed and sold in the UK. Never really made it to the US, but that's where it came out of. But ARM went along for decades before it became important to the rest of the industry, because the rest of the industry had to decide to adopt the ARM architecture, which turns out was really good for mobile phones. Which is where they came over. And I sent you the Steve Ballmer thing, but it's really interesting. It's worth spending an hour and a half listening to it. Just viewers go to acquired.fm and listen to Steve Ballmer's interview. The sort of fundamental problem that Microsoft had that he acknowledged in this interview is they thought Windows was everything. So they tried to apply Windows to everything, including a phone.
Yes,
But they had to use an Intel chip, and the phones sucked, and they never sold very many of them, and they had to get out of that business, and then they went and bought Nokia. That's a whole different story. But so they tried to apply Windows to the server. They applied it to the personal computer. They tried to put a pad. They tried to put Windows everywhere, which led them to not understand what the problem was. And he acknowledged this, right? That they were too caught up in Windows to understand what was happening with the mobile phone or with server hardware. And somehow, and this is a guy named Robbie Buck probably made this happen, with Xbox, they didn't make it a Windows machine. So, because if you want to build a dedicated game computer, you don't want to do it like with a general purpose operating system. It's like
general purpose
fundamental
system. Interesting. So,
which is designed to handle applications that do anything. Right?
Yeah, interesting.
But a game computer only plays games. That's why GPUs became much more important for a game device than the CPU.
That's really interesting. The general purpose operating system is for humans to interact with computers.
Well, for generalized computers. I mean, you can have a computer people don't deal with. This is one of the, here, this is a little thing that I figured out.
Yeah.
If you go to, I don't know if this is still true, but by and large, at least 10 years ago, if you went to check into an airline, there was a Windows machine behind the counter.
Yep.
And half the time you'd see people skipping from one computer to another because it would crash. But it was really cheap, general purpose computer that could show the agent what was going on in the online system, the reservation system, to do check-in and whatever else they do there. And all the Windows machines out there, there was some percentage that were not used by a person. It was not personal. And it was a computer that was used as a dedicated machine for whatever they were doing, like airline clerks. And so they'd say, well, Windows has 90% of the market. And you go, but what about 30% of Windows is not somebody like buys software and puts it on a computer. So they were using a general purpose computer as a dedicated device. And so you always have to look at kind of what's the truth about all these statements about market share.
So what
that was one of my things. I used to beat on that drum all the time, and people go like, "That guy's just irrelevant."
It's just so. I guess this is why I'm so interested in the 1960s. Was because the 1960s, the countercultural revolution led to the PC, or well, actually, that'd be a good question to ask you. Did it lead to the PC industry? I guess you can't say that, like, because it's history, right? It's all
it's just about age. It's what I've been talking about. They happen to be born at a time when, over time, they became adults when the microprocessor happened. So they could have a personal computer. So the people that started personal computer companies tended to be the age of people that went through the 60s and early 70s.
So the culture of that thing got into the PC at this individual level. But then,
and at the time, the personal computer was a separate ecosystem. Like there were no mainframe or mini computer people in the personal computer business.
Yeah.
Right. So they were isolated. There was no network, right? So it was isolated. And that's why my conferences always felt like a kind of a frat house, because they were all the people that got together. And they're all like in the same business, but didn't have to deal with the rest of the world. So it was like a closed system.
Ooh, that leads me to another interesting question, which is like, what happened when the rest of the world started paying attention? Because that was probably in 1994 to 2000.
It was progressive, right? It was progressive, but it started when the network happened, when the internet happened.
Yeah.
It broke down the barriers between different parts. Plus, the personal computer kind of took over. This is my point about predicting the end of the mainframe. Like everybody thinks I was wrong. I had to eat my words in the IBM annual report. But this was just like a shtick that I did, because the point was the microprocessor would scale and become more and more powerful, and it would no longer require these big hunky machines.
But then, and that leads us right to, where does it all go with LLMs? Because it's getting really interesting. Before we started recording, I now experience zero blockages to building any software I want. I'm not coding anything. Whatever idea I have, I can now translate it into software, and it works.
There's still limits to that for commercial, professional software. Stuff you're going to sell.
Well. So yeah, scaling it. So yeah, right now it's just
You
prototype.
can't
I'm just
vibe
using
code
it.
an operating system. You
But
can't
yeah,
vibe
okay,
code.
yet.
Yeah.
But so yes, you're right. And I don't make any claims to the opposite. I'm not saying that I'm building software for 1 million people. That's definitely not happening. But I don't think I need to anymore because I don't think anyone else needs to anymore. Like maybe the personal computer is turning into a personal software where it's like I'm building software for myself for a few other people. So I don't need performance for millions of people. And yeah, I just got a great. So now I can read the terms of service. So I can read the terms of service that any the check marks with the 25 pages that everybody has to sign because they can't read it because they just want to get something done on their computer. Turns out that that's part of a law from the United States about property laws that they just need to do that for the contract. Regardless, nobody's ever read it.
It's liability, but not property.
0.1% of the people actually read that. It's probably only the lawyers are reading it.
I don't think it's even 0.1% anymore.
Yeah.
It's like the little pop-up that says,
reject all cookies.
Do you accept my cookies?
Yeah.
Like that's a EU rule that made us all have to dismiss that fucking pop-up.
But
you can read it because you give it to ChatGPT or
exactly.
whatever.
Now I can get the point out of it. Yeah. And so now I get and so I signed into Carta, CARTA, the website, and I found out they just released a new one. And it was crazy. It was crazy what was in that. And it's all related to AI because they're all doing their reinforcement learning labs. They're building RL gyms.
But Carta changed their terms of service?
Yes, they did. Specifically to say, if you sue us, good luck. If you sue us, good luck. We're going to take all of your data. We're going to trade an RL environment. This is me paraphrasing it. But basically, all your data is ours now. We're going to train models on it. We're going to train models specifically for RL labs so that we can have agents navigate the entire Carta system. So that you can and they're all doing it. I bet you every single company is now doing exactly what Carta.
But Carta has cap tables for all the startup companies.
Interesting.
That's like, oh my God, that's actually protected financial data. It's supposed to be super secure. Excuse me.
They anonymize it, so they get around it. There's a specific way they can anonymize
identifiable.
Yeah.
Excuse me.
So, but why I said that is like that makes me never want to trust anything in the cloud ever again because, so I don't see how all companies.
Well, you just raised the T word, trust.
Trust, yeah.
Trust is not a mechanical thing.
Yeah.
It's
I would like that.
If you lose trust, and the United States government has lost trust, that's part of why we have Trump.
Yeah.
Like nobody believes that the government is competent, whether you believe it's a deep state or just bureaucrats. Yeah. Nobody believes that the federal government of the United States of America is competent, that it can make anything happen. So it's part of why Trump is doing the good thing because he's kind of eviscerating government so he can rebuild it. That's a multi-layered.
Yeah, let's go back to Carta. What do you think about Carta as a company? Because that seems like an interesting sort of like.
It's a horrible company, truly horrible.
Yeah.
By all my metrics, it really doesn't give a shit about its customers.
Yeah, interesting.
It's there to make money. And the guy who started it has said this publicly. So they got everybody to put their cap tables on Carta. The database they use, the system, like I can't modify my profile. I have to call them up to get them to do it. It's just really bad software.
Yeah.
And then they decided to, this was a few years ago, they decided to make a market in startups because they had all the cap tables.
Yeah.
Like they had perfect data.
Yeah.
They decided, this is way before they changed the terms of service, they decided to start using what they knew about startups to sell stock in startups to create a market, which is like, what the fuck are you talking about? You're supposed to be a trusted provider of cap table information so that I, as a venture capital firm or as an angel investor, can manage my investments. And you're going to go start selling the stock. I don't think it went anywhere because it was too far. But this is a company that, I've been using it. We have all of our portfolio companies in our firm, and most of my angel investments are on Carta. And they just do a terrible job. It's a horrible thing to have to deal with it.
Are there competitors?
No. They got into it far enough that it's, there are, but they haven't been able to get anywhere.
I wonder if I could vibe code my own, because it only matters. It's a interesting. It's a niche that they essentially colonized pretty well.
It's a really complicated thing because stock in private companies has all these terms associated with them, and they didn't actually try to normalize it. They just kind of created a database where it got stored.
Yeah, interesting.
I just read a story about how, again, in the Wall Street Journal, the whole idea of democratizing investing in private companies. It's a really sexy thing, But the way the system has evolved, because the way they set the rules up with the SEC and is that only rich people can invest in private companies. So rich people are getting richer, and the poor people can't get access to it. Just read that article yesterday, and either you open it up or you don't. It's like you don't go halfway, because then you create a bigger problem. And this is incrementalism, which is a whole nother topic. But, people
now it's opening up all the way.
Changing things. Well, crypto is in theory the democratization of investing.
Not only crypto, but gambling, call sheet, and poly market, and then sports betting is now becoming tax free.
Yeah, but that gambling, you don't actually own anything. You're just gambling.
Yeah, that's
owning
a really good.
You bought. I can't remember how you bought like 6 Bitcoin when you were 10 years ago or whatever it was, when it was like a couple $100 each, right?
Yeah, probably shouldn't talk about it anywhere because they'll
go after you.
Yeah.
Well, try to get your wallet, right? Because the wallet is not secure. Yeah, the distributed ledger is great, but they can whack wallets. They know how to get into them.
Well, and it's related to what I was about to say about Polymarket. Is there's this very interesting thing, because the whole thing about Bitcoin is that it's censorless, right? So you can't actually censor transaction. If two parties want to transact together, they don't need to use Swift, which I now understand. I now understand what Swift is, which is really interesting. And so BTC allows two people to transact with no third party. What that does is what you just said, where it allows some other third party who's untrustworthy character, like it's happened in Ukraine recently. It's happening a bunch in France, where they go after people and stuff. I definitely don't have enough to do anything like that. So don't nobody listen to this think about that. But so basically,
he doesn't have any money, so don't go after him.
Yeah. I'm poor. I'm living in Argentina,
which is the essence of security. If you don't have any money, it doesn't matter. They're not going to. They can hack you, but then what are they going to get? What they really want are the billionaires.
Yes. Well, yes. Okay. And so the censorless part, and so maybe I don't think we probably talked about this yet. A lot of people, once Trump got elected, everybody, Trump's like, okay, free crypto markets, crypto, everybody can do crypto now.
Rules.
Well, there are some rules. This is the most interesting thing, is that the stable coin, nobody watched it as it was happening. He created something called the Genius Act, and the Genius Act made all of the stablecoin emitters turn into banks. So now all the banks are becoming stablecoin emitters. All the stablecoin emitters are becoming banks. And what does that mean? That means that any stablecoin emitter operating in the United States needs to be able to censor any transaction according to the US government, which is the opposite of what crypto was about. So basically, Trump, actually, it was a genius act. It was a genius act to essentially capture this thing that was outside of their control, put it under the United States control, and make a one-to-one USDT, or any stable coin needs to have $1. $1 in treasuries in order to back it, in order to operate legally in the United States. And they need to be able to program it so that if the DOJ comes to them and says, you need to stop this guy from transacting, you can do that. So that's the way that it now works. Anybody who wants to operate in the United States needs to do that. Meanwhile, Tether was really interesting. Tether is the number one outside the United States stablecoin that is going to operate in the United States under those conditions, but also has operations everywhere in the world, including Argentina. They just they're now diversifying away from USD. They're going to keep their US operations with the treasuries, but they're now investing in gold. They're making a bid for the largest Argentine fertilizer company in the world to get into fertilizer. They're getting into gold. They're doing all these different things to essentially like diversify out of the US dollar. All that to be said, though, Bitcoin is also getting captured as well, because now a huge amount of the Bitcoin is underneath regulatory pressure as well. So it's not actually holding that original value of being sensorless, of being,
You know who Michael Saylor is?
Yep. He's got an interesting point coming up in January where his stock, I can't remember the specific details, but there's some point at which if the price of Bitcoin doesn't go up, he's coming into trouble in January.
He borrowed money.
Yeah,
to buy Bitcoin.
Yeah, exactly.
So he's leveraged.
Yeah,
leverage is always a problem.
Yeah, yeah.
Yeah, it looked great while Bitcoin's going like this. But when it stabilizes or it goes down like it has in the last few months, that creates a problem, because then you get exposed to your leverage. It's exactly what happened in 1929. That's why everybody is like sitting here wigged out about crypto, because crypto might be the new 1929.
Well, I think that happened
2029.
Well, that happened in 22, where it was a wipeout with FTX. A lot of people, I asked people on my podcast, like, "Oh, well, what happened? Like, what happens if 1929 happens?" And some guy was like, "Oh, it already happened in 22." And I got caught up in that. I don't remember. I was trying to sell my house, and it was a huge challenge. Not because I overinvested in anything in FTX or lost any money, but because it brought down the whole market. And all the
mortgage.
Yeah, and the mortgage.
And you have a mortgage.
Became house
mortgage is leverage. You leveraged your house.
Yeah.
It's officially condoned, but anyway, yeah. So I'll promote a little bit here. There's a fellow named Benedict Devins, and if you're on Threads, you've probably seen his post, because he posts 2 or 3 times a day. And he makes interesting points, and so I pay attention to him. The reason I started using Telegram is he said, you should do shadow trading. I think that's the term he used. And I said, okay, so what's that about? We've been in a week-long conversation, because in order to shadow trade on his trades, which are in stock, I have to buy crypto. Oh, I'm back into that. Like, how the hell do you buy crypto? So he referred me to something called Paybis, Paybis, which is an app for buying crypto and transferring money. And the user interface on it is so bad that, I didn't copy the link, the number, the huge long number, out of it before it refreshed.
Yep.
So I lost the link to what I was going to do.
Yep.
And I couldn't find it, couldn't go back to it. And I got all wrapped up in this, and I'm doing it between everything else I'm doing. But he told me about Cash App, and Cash App originally would not link to my debit account, but then it did. Like magically it did. So I moved $200 into my Cash App account, where I can buy only Bitcoin. So then I'm like, okay. So he said, no, go buy the Bitcoin, and then you can transfer that on the other app. And I'm going like, this is so fucking complicated. If you're a normal human being and not doing this full time, it's just like, it's painful.
Yeah.
And that's at the level of like user interface and user experience. It's like, it's so bad.
Yeah.
So why hasn't anybody been able to, like Dropbox did for file storage in the cloud? Why hasn't somebody done the Dropbox for crypto?
So no, they're coming. There will be agents that will take care of all that nonsense, and it is nonsense. It is totally. It has been really interesting.
No, but the nonsense is that huge number that gives you access to your wallet is hackable, and then but it doesn't map onto anything else. It's like it's a huge string of numbers, and I don't know what the hell they mean. So I don't even know what that is. And
Ethereum tried to get around that by having an address that, like the DNS address, that would convert into characters, because that's the same thing. It's that string is your public address, and what that is your IP address for you or for your wallet.
For my wallet, It's like it doesn't look like anything else I use to deal with cash. It's not like logging into a bank or using Venmo or.
That's the crazy part, is that this crypto thing, is 2013, was a bunch of cypherpunks who are all doing PGP encryption, who are doing like crazy stuff where that number is totally normal to them because they're developing. And then the funniest part is that a bunch of Ponzi schemers and charlatans came in and made billions of dollars and are now like interfacing with large politicians and then also happen within the politicians as well. And so now we're in this just sort of late stage where there's all this talk of crypto, all this hype, but none of them have done anything to solve that fundamental problem. It just like sucks so much.
Usability.
And you can't,
Yeah.
so your Bitcoin can't transfer out of Bitcoin network to anything, which is good. I think that's good to have it in the Bitcoin network. Cardano is now building on top of Bitcoin, so they'll be able to transact between them. Same thing with Ethereum. Ethereum, you can't switch your Ethereum for Bitcoin except if you bridge it. Yeah, there's all the
Right over my head.
It's extremely.
This is all Greek to me. I have no idea what you're talking about.
Yeah.
Like, all power to you. I hope you make a lot of money, but I can't figure it out. And the way I make money is like the old way.
Yeah. Well, and afterwards we can talk about how to do shadow trades. But actually, to end, what did he mean by doing a shadow trade on Telegram on his stocks?
So, can you free up a few $100 and shadow trade on them?
Oh yeah. No, I can do that, but I don't know what it means.
Connect here. The two people I'm connected to on Telegram are you and he. So I'll send you both a message and say, Benedict, go get my son. He knows what he's talking about.
Let's do that. Okay.
Oh.